Hello, today we are going to be discussing functions. Please take a minute and watch the video that is over here linked on the right hand side. It is a short video that gives you an introduction to functions. So, you will be completing your notes as we go through, so please make sure that you fill in your name and your section. Our objective today is that scholars will define functions and be able to distinguish between functions and non-functions. Functions and non-functions. So, on the first slide you see this, we have relation and function. A relation is any set of ordered pairs or graph. Anything that relates one set of numbers to another. It relates one set of numbers to another. That is what a relation is. A function is a special type of relation a special type of relation where each input has exactly one output. Please make sure you get this definition down for each of these. A relation, again, is any set of ordered pairs. It relates one set of numbers to another. Sometimes you'll see them on graphs, sometimes you see the ordered pairs, sometimes you see them in tables. A function, on the other hand, is a special type of relation. Each input has one output. So now let's talk about some vocabulary that you need as we are discussing functions. First one is domain. Domain is the set of all inputs. The set of all input values. Domain is also your x values. Domain means we're talking about x values. X is your input. It is also called the independent variable. X is your input is your domain. So input, domain, x value, and independent variable all mean the same thing. The other word that you need to know is range. So if domain is the set of all inputs, your range is the set of all outputs. So the set of all output values. It is your y values. It is also called the dependent variable. Your output, your y value, depends on what your input is. So, once again, domain is input, x value, and independent variable. Range is your outputs, your y values, and your dependent variables. Please make sure you get these down. We have a function machine. We have our input of -4 giving us an output of 11. And we're going to try to determine the rule. You can see our 4 and our 11 right here. So, I'm going to look at how much it changes between each time. So to go from 10 to 1, it subtracts 10. To go from 4 to -1, it subtracts 5. To go from 1 to 7, it adds 6. From -1 to 2, it adds 3. And all we're going to do is do our change in our y. So -10 divided by negative 5. We're finding our rate of change. Well, negative 10 divided by negative 5 gives me 2. So now I know my rate of change is 2. And then I need to figure out, so if I take 4 and multiply it times 2, that gives me 8. But I don't need 8, I need 11. So we're going to add 3 to it. Now let's double check it with this one. 2 times 2 is 4, plus 3 does give me 7. So there's my rule. 2x plus 3. So that's my rule. Y equals 2x plus 3. This is one way you'll see functions represented. And you can choose another couple numbers. Let's say I put 1 in. If I put 1 in, 1 times 2 is 2, plus 3 is 5. If I put 3 in, 3 times 2 is 6, plus 3 is 9. If I put 5 in, 5 times 2 is 10, plus 3 is 13. You can see that we can use the rule to generate different inputs and outputs. So now let's talk about how we can tell if it is a function. So is it a function? And this is from a table. So what are we looking for to tell if this is a function? So example 1, remember that our definition is a function for each input has one output. So let's look at the inputs and outputs. So example 1, input of negative 1 gives me an output of 4, okay. An input of 3 gives me an output of 2, cool. An input of 5 gives me an output of 5, fine. An input of negative 1, well, I've got a problem now. I already had an input of negative 1, right? And this is not the same output. So this one is not a function because I had the same input twice with different outputs. Now let's look at example 2. So example 2, I have an input of 9 with an output of 3, that's fine. An input of 3 with an output of 2, fine. Input of 6 with an output of negative 1, that's fine. An input of 0 with an output of 1, that's fine. Input of 8 with an output of 1. Even though these repeat, that is allowed. You can get the same output for different inputs, but each input can only have one output. So this one is a function because each of my inputs only has one output. So you write that each input, which is our x, right, has one output. So that is a function. And let's look at the very last thing. How can we tell if something is a function if we're looking at a graph? So from a graph, what we're going to do is we're going to look to see if our inputs, remember our inputs are what? So input is x and output is y. So I'm looking to see if my inputs have more than one output. So when I look here, I have an input here. Remember, my x value is my horizontal value. That's my x, right? So I need to see if any of my inputs repeat. This has an input of negative 5. This has an input of 2, an input of 3, an input of 5. So this one is a function because none of my inputs repeat. When I come to the next one, here I have an input of 3, and here I have another input of 3. See how the points are directly above each other and below each other? They have the same x value. This one is not a function. If any function has spots directly above and below each other, it's not a function. So let's look at the next one. This one, again, I have two spots directly above each other. So it is not a function. It does not matter if they're on the same horizontal line, it's on the same vertical line. That is an issue. So now let's come down and look at these bottom ones. This first one, if I look at an x value here, I also have another y value there. So they have two y values. Not a function. A circle definitely has points directly above and below each other. It is not a function. And finally, I have this weird looking thing, right? But there are no points directly above and below each other. This one is a function. Take some time to work on your classwork and then take your mastery check. You all have a great day.